Now, dear children, we will go to the next next topic from this chapter. After we learned about the energy band in solid or material. Okay. Now, energy band are different types. That means we now discuss the types of energy band, and we see this energy band in different substances like conductor, insulator, semiconductor, and all. Okay. So, energy band are basically classified into two types, and this classification is on the basis of the position of the electrons occur by the valence electron, and even the position occur by the electrons called free electrons. So on the basis of position, okay, and occur by the number of valence electron in an atom of solid in the solid, okay, crystal, or by the conduction of free electrons in a solid or crystal. So energy band are basically classified into two types. One is called conduction band, which is marked by letter CB. The conduction band is basically an empty. It is an empty, or it can be partially filled energy band. It will be an empty band also, like you learn when it will be empty band, when in case of insulator and all, and it will be partially filled energy band in case of conductor and all, okay, just above the what band? Valence band. So empty or partially filled energy band just above the valence band, occupied by what electrons? Free electrons or conduction electrons, and such band is called conduction band. So the word conduction is also related to free electrons. Because you know that when a substance, when we talk about the substance, the classification of substance is also based on the basis of free electrons. And you know, in case of conductor, there are large number of what electrons? Free electrons. Like insulator, there is no free electrons. Okay. So on the basis of that, empty band, or it can be partially filled energy band, which is just above the valence band, occupied by which electron? Free electron or conduction electrons are called conduction band. Okay. Now, similarly, we have another band called valence band. You know the word valence is related to the electron called the electron present in the outermost orbit. And this electron are called valence electron. So, this valence electron in the outermost orbit can also form energy band in a solid or crystal. And this band is called valence band. So, what is valence band? Completely filled energy band. So, listen. Completely filled energy band occupied by what? Which electron? Valence electron in a solid or crystal is known as valence band, and we mark by letter what? BB. So these are the two band, okay, which can be observed in any of the solid, whether it's a solid like semiconductor, insulator, or conductor. And on the basis of this energy band only, we can classify the solid as conductor, insulator, or a semiconductor also. Now we have next that we need to define and to know between the two band, which is called conduction band and valence band. See, conduction band and valence band, okay, has an energy gap. There is a gap or space between the conduction and valence band, and this gap is such a gap where there is no electrons are allowed to stay in the gap. Okay, so that means such gap or space is also expressed by the energy gap, and this energy gap is also called forbidden energy gap. Forbidden means strictly not allowed. That means no electrons can allowed to stay in the band. Okay, that's why the space between the valence and conduction band, which cannot be occupied by any electrons, any of the electrons, is called what band? Forbidden energy gap. And this is simply marked by letter EG. Capital letter EG is the symbol we use for forbidden energy gap, or simply called as energy gap. That's why I already said that in this energy gap, no electrons are allowed to stay in this gap. So that means energy can never remain in this energy gap, where electron can remain in either valence band or in what band? Conduction band. Then other than valence band and conduction band, there are other lower energy band also. But when we do the classification of substances, we do only with the two bands. One is called valence band and conduction band. Okay, but between valence and conduction band, there is a gap or space between these two bands, and this space is called forbidden energy gap, also expressed by letter EG. And this energy gap is basically measured in the unit electron volt. What unit? Electron volt. Because electron volt is also the unit of energy, and we measure this energy gap in the unit electron volt. Now with this concept of types of energy band, we now classify substance on the basis of energy band. So now we discuss energy band diagram of conductor. Okay, like conductor like sodium, beryllium, okay, potassium. These are the conductor which are called metals, and this conductor has energy band. So energy band diagram of conductors, and this is basically important for your examination also. So you'll be asked to draw the energy band diagram of conductor. Now in case of conductor, conduction band, as you know, energy band always overlap with each other. Okay, that means there is no energy gap between the two band, conduction band and valence band, because you know in conductor, okay, other than the free valence electron, there are the free electrons, large number of free electrons, and these free electrons are already atoms of the conductors always acquire what? Electron, large number of free electrons, and due to that free electrons or conduction electron, they already acquire a band, and that band is called conduction band or valence conduction band. But other than the conduction band, there is a valence band. But due to large number of free electron present in a conductor, these two bands, conduction band and valence band, are mutually overlap with each other. Okay, so that's why you can see in the diagram, this is a conduction band and this is a what band? Valence band. So these two bands has mutually overlap each other. So they always mutually overlap with each other. That's why in conductor, conduction band overlap with the valence band, so that valence electron can easily jump into the which band? Conduction band. That means there is no energy gap between the conduction band and valence band. Okay, that's why no forbidden energy gap all present in conduction band and valence band in what? Conductor. But in case of conductor, if an electric field is applied, electric field applied means when conductor is connected to our cell or battery, because when conductor is connected to a cell or battery or cell supply what field? Electric field. Okay, due to this electric field applied across the conductor, the electrons in the partially filled which band? Valence band, easily acquire some additional energy, and this energy is actually in the form of kinetic energy. The energy acquired by the electrons is what energy? Kinetic energy. And due to this additional energy, these electrons present in the partially filled valence band can easily move to the which band? Higher unoccupied energy level within the same band, in the what band? Same band. So without crossing any energy gap. That's why this additional energy that we can see in the form of kinetic energy of the electrons, and this energy that get by the electrons is due to the what? Due to the conductor which is connected to the electric field. So under this case, what happened? The moving electrons which are already acquire a band that is called conduction band, okay, constitute an current, and this current is called electric current. That's why children, you know that in conductor, okay, the main charge carrier to constitute electric current are the electrons, and these electrons are called what electron? Free electrons. And you know free electrons are present in the conduction band, and this free electron already occur in the conduction band, okay, because of there is no energy gap. But only thing is that when that conductor is connected to the electric field, these electrons acquire additional kinetic energy, and due to that they start moving, okay, across the conductor, across the length of the conductor, and due to that they constitute electric current. Now, as you know, there are many metals which are called conductors, like sodium, beryllium. These are the metals, commonly used metal, which are good conductor of electricity, because there is no energy gap between the conduction and valence band, and electrons in the conduction band, they can easily move in the across the length of the conductor when that conductor is connected to the electric field. That's why in conductors, valence band is self in the which band? Conduction band. So remember that the only solid where the valence band is overlapping with the conduction band is called conductor. Whereas you can see for other substances like semiconductor and insulator, there will be a gap between the conduction band and valence band. Okay, that's why among these substances, conductor are always used to conduct electricity. That means they are used to supply current in an electric circuit. Okay, that means they are the good conductor of electricity. Now, this is the simple energy band diagram of conductor, and this energy band diagram is true for any of the conductor, whether it's a metal or beryllium or other substances. Okay, now we do continue with the energy band of other substances, and that you learn in the next class. Thank you so much.